I'm Whitney. Welcome to Wyzant's Getting Ready for Calculus. Thanks for joining me today. Today we'll be talking about the unit circle. If you're just starting calculus, it's a great review from last year, and if you're in pre-calculus this year, you'll be covering it soon. If you have any questions, please drop them in the Q&A, and I'll try to help you with some answers. We should have time left over at the end for Q&A as well. Let's get started. Okay, so before we get into the unit circle, this is what the unit circle looks like, but let's go back a little bit and start talking about Sohcahtoa, and I think that'll help form a little bit of baseline. Okay, so Sohcahtoa is a way to remember sine, cosine, and tangent. Sohcahtoa. It's spelled exactly like you pronounce it. So what it's telling you is that sine of theta is opposite over hypotenuse. So it always goes in the same order. So it's what's on this side, what's on top, what's on bottom. Cosine theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. These only work for right triangles. There are ways that you can use them to solve non-right triangles. That goes into law of sines and cosines. But in general, if you're using these relationships and these ratios to find them, you're talking about a right triangle. So let's look at a few examples. Let's say we have a right triangle, and we know this side is, we're trying to find, we know this side is 5. And let's say we know the angle is 30 degrees. In order to figure out what x is, you want to identify what two things you have and what thing you're looking for. So we have this angle here, and everything is relative to the angle that you're actually talking about. So for this 30-degree angle, this is the opposite side, this is the adjacent side, and this is your hypotenuse. Had I been talking about the angle over here, then your opposite side is across from it, and the adjacent side is right next to it, because adjacent just means right next to. So we have the opposite in the hypotenuse in the angle. So we want to use sine, because we are looking for the opposite. We have the hypotenuse, and we can plug in the angle. So we can write out sine of theta is equal to opposite over hypotenuse and plug in what we know. So we can say sine of 30 is equal to x over 5. And then you can go through and say x is equal to 5 sine 30. Once you know the unit circle, you'll be able to know what sine 30 is off the top of your head. But if you don't know the unit circle, you can just use your calculator if you're allowed to do that. Let's look at another example. Another right triangle. Let's say that now we know this angle is 29 degrees. We don't know this side, and we know this side. So we're looking at the opposite side that we know and the adjacent side that we don't know. So we don't want to use sine because we don't know anything about the hypotenuse and we don't care about it. Cosine, same thing. We don't know about the hypotenuse and we don't care about it. Tangent, we know the opposite side and we want to find the adjacent side and have it. So we can say tan theta is equal to opposite over adjacent. And then plug in what we know. So we're plugging in the 29 angle. Opposite of that is 6. And the adjacent side is x. This one's a little trickier as far as solving because x is on bottom this time, so we can't just multiply out like we did last time. We'll still do that, but we'll have one more step. So we get x equal to 6 over 2. Okay, the only other type of situation you'll run into is if you don't have the angle. So let's say we're looking for this angle and we know that this side is 4, you're still trying to figure out which one you're going to use based on we have the adjacent side and we have the hypotenuse. So that tells us that we're going to want to use cosine. So we'll say cosine of theta is equal to 4 over 15. And what we want to do with that is we want to take the inverse of both sides. because we need to break out this theta. We can't just divide by cosine since it's a function. But if you do cosine inverse of 4 over 15, that'll spit out your theta. And be really careful. So this -1 doesn't mean like 1 over cosine like exponent rules normally mean. Here it means the inverse. So it means either arctan or inverse cosine. Sorry, not arctan. Arc cosine or inverse cosine will both give you the same thing because they're the same. They're just different ways of calling the same function. And you should have that button on your calculator just by putting in, most of the time it's like right over cosine, so you have to like hit the second key. Okay, one other thing that I wanted to kind of talk about while we're on this is that sine of theta is equal to cosine of 90 minus theta. If you're taking your SAT this upcoming semester, this is something that pops up every so often on the SAT. So it's really good to have that in the back of your mind. And basically the reason why it works is if I'm talking about this is being theta, this is a right triangle. I know all my angles add up to 180. So because of that, this has to be 90 minus theta. The opposite side for this angle is this side. The adjacent side for this angle is this side. Hypotenuse is the same always. The hypotenuse is always across from the right angle. For this angle though, this side's my opposite and this side's my adjacent. So let's say that we had a 4, 3, 5 triangle, which is a really common triangle you'll see a lot. It's called a Pythagorean triple. If I was doing the red one, right? If I was doing sine of this angle up here, or actually let's do cosine. Let's say we're doing cosine of 90 minus theta. That's going to give me the adjacent over the hypotenuse. So that's going to be 4 over 5. If I did sine of theta though, that one, now my opposite is 4 and my hypotenuse is still 5. So I'm getting the same thing out of both of them. And it just has to do with which one you're calling opposite and which one you're calling adjacent. Okay. That's pretty much all I wanted to go over with Sohcahtoa. The other things that you kind of want to watch out for are the ones that are the other trig functions. So we have cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. Cotan theta is 1 over tan theta. And tan theta is sine over cosine. So as long as you can get sine and cosine, you can get the rest of them. Okay, so for instance, let's say that we have a triangle again. Let's say that this is theta and this is 8, or actually we'll do the 4, 5. Let's see, 4, 3, 5 triangle. Let's say that we want to find secant theta. The way I remember which one's which is it flips from numerator to denominator, and the S and the C switch too. So secant theta I know is 1 over cosine theta. If I was trying to find cosine theta for this angle, I know it's adjacent over hypotenuse, so I'm going to do 3 over 5. So I have 3 over 5 here. And just remember that when we're dividing fractions, we can keep the top one the same, and then multiply the bottom one. Multiply and then flip the bottom one. So we get 5 over 3. And that's the same, the reciprocal of what we would have got if we got cosine. And then tangent of this angle, I know it's opposite over adjacent, so it's 4 over 3, but that's the same thing I would have got if I did sine and I put that over cosine. So either way you want to think about tangent totally works. Okay, let's see. Before we get started on the unit circle, we need to talk a little bit about radians. So the unit circle goes around 0 to 360 degrees. If you haven't talked about radians in class at all yet, radians are just a different way of measuring angles. It's kind of like doing feet versus meters for measuring distance. So if I'm going to 30 degrees, that's the same thing as saying I went to pi 6. So the main ones you need to know are on this unit circle, but if you had a different one that you were looking for, you can always set up the proportion. there are 2 pi radians in a circle, and then there's 360 degrees in a circle. So you can say part over whole. So radians over 2 pi equals degrees over 360. Plug in what you know and then try to find the other one. So let's do an example. So say we want to change 40 degrees into radians. Since I know the degree, I'm going to plug that in. So I'll say 40 over 360, and then radians I'm looking for, so I'll leave that as rad there, and then I'll put 2 pi here. And then you could just multiply the 2 pi up and simplify. Same thing if you're trying to change something from radians to degrees. So like, let's say that we had 7 pi sixths. If you have the unit circle handle and it's on the unit circle, you could just go see where it's at. Otherwise, we could plug into here. So we could say 7 pi over 6 all over 2 pi is equal to degrees over 360. The pi's will cancel out, and we will end up with, let's see, 7 times 360 over 6 times 2. Whatever that simplifies to is going to give us our degree answer. Okay, the key things on the unit circle that you need to know are that this is 0 degrees. It's also 0 radians. This is 90 degrees, but it's also pi over 2 radians. This one's 180 degrees, and that's pi radians. And then this is 3 pi over 2 and 270 degrees. So if you know the degree and the radian equivalents, you can kind of like figure out where any of them that they give you fall into. So if you know it's between 0 and pi halves, it's somewhere in the first quadrant. And that's really the most of what we care about, is like which quadrant something falls into. Okay. There are different ways to write angles. So if I said the angle of negative 60 degrees, what that means is, because normally we go this way, the negative just means we go in the opposite direction. So we're going to go 60 degrees this way. That's just going to be at 300 degrees. So another way I could write that is 300 degrees. And that would be what we would want to write if it was between 0 and 360. Say they gave us negative 60 and they wanted it in radians. We could just use that same conversion that we used before. Okay, let's say that they gave us a different angle. Let's say that they're giving us negative 225 degrees. Another way we could do it, we can definitely sketch out negative 225 this way, but you can always add or subtract 360 until you get into the 0 to 360 range that you want to be in. So if I add 360 to negative 225, I'm going to get 135. So I know that I'm at this angle here. And that makes sense, because if I went 225 degrees is this much this way, that means it's that much this way as well, if you're going negative. Let's see, what's another one? 495 degrees. That one's bigger than 360, so I can just subtract 360 degrees out of it. And I will get also 135. So these were all different ways that we can say 135 and get to the same spot. It doesn't matter at all how many times you go around the circle. It's just all about which quadrant you end up in, like how far away it is from the x-axis. Okay, and then same thing if it was like 1200 degrees. That's just a more extreme one, right? So that one you can subtract out 360. You're still over 360, so you subtract out another 360, and you'll get down eventually to something between 0 and 360. Okay. The same thing works for radians. The only difference is you would want to subtract out 2 pi. So like, let's say that we're at an angle of 5 pi. What I could do is I could subtract out 2 pi. I'm still going to be bigger than 2 pi, so then I could subtract out another 2 pi. And now I'm between 0 and 2 pi. This was a really clean answer, but it could have been fractions as well, and you'd still do the same thing. Okay. So now to start that's kind of the background information we need for the unit circle. To start thinking about like what everything says, it's really helpful that it has all these degrees to radian conversions on it. But the most important part of the unit circle are these coordinate points. So what they say is that you have cosine of x here and sine of x here. So let's say you wanted to know cosine of 120. You'd go to the 120 line and you'd look at what the left side of it is. And the reason why that happens, some pre-calc classes go into this, but it's special right triangles. And it's always with the x-axis. So here, 120 to 180 is 60 degrees. So you can form this 60-30 right triangle where you have a radius of 1, because your unit circle always has a radius of 1. So that gets you your x-coordinate, but it also happens to be what cosine is. Let's see. If, let's say you wanted to do sine of 225. If you look there, it's this one's cosine, this one's sine, so it would just be this guy, negative root 2 over 2. And don't be confused, if you look at a different unit circle, it might say negative 1 over root 2. Those are the same exact things. The only difference is one of them is rationalized and one of them is not. So this one, it's technically bad to have square roots on bottom, but usually once you get to calculus, nobody really cares anymore. Okay. Let's see. These are only sines and cosines. So if you wanted a different function, like say you wanted tan of theta, let's say that we want to find tan of, let's do tan of pi. We know from before that tan is the same thing as sine over cosine, so we can just sub that in. Sine here is going to be 0. Cosine here is going to be negative 1. So then you can know that your answer is going to be 0. Same thing for like all the reciprocal function trigs. So if you wanted to find secant theta, you know that's 1 over cosine theta. So you would just, whatever angle you're talking about, just read out what the cosine is in that left side. Okay. So that's pretty much how you read the unit circle. The unit circle is very hard to memorize if you want to memorize all 4 quadrants. It's much easier to memorize the first quadrant and then memorize the rules for the other quadrants. So we'll talk a little bit about how to do that, so you don't have to spend a couple hours memorizing it. One of the big things is like where sine and cosine are negative. So if you look, some of these are positive, some of them are negative. Since we write it out as cosine x, sine x, that's our x and y points. On the unit circle, cosine is x and sine is y. Sorry, these should be x's. So where x is positive, cosine is positive. And if you look at all of the x coordinates, they're all positive there. And then over in this region where x would be negative, you're going to have all negative cosines. Sine is the y, so anywhere where y is positive, you're going to have a positive sign. And anywhere where y is negative, you're going to have a negative sign. Okay, let's see. Another way to memorize that is with all students take calculus. So here, all of them are positive. So sine, cosine, tangent, cotangent. Actually, I would just think about it in terms of sine, cosine, and tangent, because then you'll have to relate it to those if you're doing one of the reciprocal functions. So here, sine, cosine, and tangent are positive. Here, sine is the only one that's positive. So cosine is negative and tangent is negative. Here, tangent's the only one that's positive, and that's because we're dividing sine by cosine and they're both negative, so it cancels out. And then in this quadrant, only cosine is positive. So that stood for all students take calculus, and then whichever one is there is the one that's positive. Either way, to remember the signs is going to help you out. Okay, the other thing you really need to know if you're going to relate the first quadrant to the other quadrants are reference angles. So reference angles are always with the x-axis. So in your first quadrant, whatever angle you're at, say you're at 45 degrees, that's your reference angle. If you're at 60 degrees, that's your reference angle because it's with the x-axis. If you were in the second quadrant somewhere, though, your reference angle would be this guy here. So that side's going to be 180 minus your theta. So if you're at 135, you could just do 180 minus 35 and get to 45. If you're in the third quadrant, your reference angle is also still going to be with the x-axis, but now it's going to be whatever your theta is minus 180. If you're in the fourth quadrant, same kind of principle. It's just going to be 360 minus the theta that you're at. These are all assuming degrees. So if you want to translate it to radians, it's going to be pi minus whatever theta it is, theta minus pi, and 2 pi minus theta to get your reference angle for each of the quadrants. You don't have to memorize that. All you have to memorize is draw it out and remember that you're trying to find that angle or this angle or this angle or this angle. Okay, now to remember the first quadrant, we have a couple of different ways that we can do that. One way is the chart method. It's my preferred way of doing it. The chart is super easy to make, so you can make it at the beginning of your test. So it's sine theta, cosine theta. And then all of your important angles. So you can either put it in degrees or radians, whatever you use the most often is totally fine. I normally do degrees just because it's faster to write. So I would put 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Those are the important ones in my quadrant, one that I care about. Make this into a table. Okay, your first step is to count up. So we're going to count up from 0, 1, 2, 3, 4. And then for cosine, we're going to count down 4, 3, 2, 1, 0. Your next step is you want to take the square root of everything. And then your last step is you'll divide every single one by 2. Okay, so just one more time, count up from 0 to 4, and then you're going to count down from 4 to 0. Take the square roots of every term and then divide by 2. There are some of these that the notation looks a little weird, but they're very simple numbers, like square root 0 over 2. That's just going to be 0. Square root 1 over 2 is just 1 over 2 because square root of 1 is 1. Square root of 4 over 2 is 2 over 2, so that's also just 1. Let's see. That's pretty much it for the chart. The other way is the hand method. So you want to take your left hand. You're thinking about this as being 0, 30, 45, 60, and 90. Whichever angle you want, you would just put your finger in. So like, let's say that we wanted to find a trig function at 60 degrees. So 0, 30, 45, 60. So I'm going to put this finger in. Cosine are the numbers on top, sine are the numbers on bottom. So, and then what you're going to do is it's number of fingers square rooted over 2. And it's basically the same thing as the chart. So either way is fine. So for our example, let's see, what were we doing? 0, 30, 40, 60. If I was trying to find cosine of 60, cosine's above, so it's just root 1 over 2. And if I check my chart, that's the same thing I have there. And then if I check this guy, the same thing I have there. So that way you can figure out what you're doing for each of them. Okay, so either way, either write down the chart or think about the finger method. Both will work. Let's try to put it to some practice. So let's try to do cosine of 13 pi over 4. And we're going to try to do it without the unit circle, but the unit circle is there so that we can check our answers at the end. Okay. So the first thing I would do is I'd figure out where 13 pi over 4 is. So 13 over 4 is 3.25. So that's bigger than 2 pi. So I want to take 13 over 4 and I want to subtract out a 2 from it. So for my angle, I'm doing 13 over 4 pi, and I'm going to subtract out 2 pi. That's going to get me 5 over 4 pi. If I didn't have this unit circle handy, what I would have to do is I always like writing this out first. Pi halves, pi, and 3 pi halves. Okay, so 5 pi fourths is a little bit bigger than 1 pi, so it's going to be in this quadrant. Your reference angle from 5 pi over 4, you're going to want to subtract out the pi because we're in this quadrant. So our reference angle is going to be pi over 4. Okay, let's just go ahead and try the hand trick. So the reference angle is what I'm using, and it'll tell me the magnitude. It won't tell me the sign. I'm going to have to think about my sign to figure out that part. But if I stick in 45, I'm trying to find cosine, so I'm looking at the fingers on top. If I was doing sine, I would do the numbers on bottom. So cosine of 13 pi over 4 is going to be root 2 over 2. And then just figure out what the sign is going to be. I'm in this quadrant. I know x's are negative there, so I know cosine has to be negative there. And then you have your answer, and we can go ahead and check it. So cosine here is negative root 2 over 2. So we did that one correctly. Okay, let's get rid of our crutch. Let's try to move down and do one without the unit circle present. Okay, so let's do, what should we do? Let's do sine of negative 5 pi over 6. Okay, so we'll draw out our circle. This one's in radians again, so I'm going to label it real quick. And once you get really used to this, you don't even have to label it or draw the circle part. You can just kind of like sketch out a coordinate axis real quick. Negative 5 pi over 6 goes back this way. It's not really a full pi, but it's bigger than pi halves. So I know I'm in this quadrant. And I have pi over 6 left to get to here. So the way that I did this is I didn't even have to figure out the positive angle first. I just tried to figure out, because this was 5 pi over 6, what this angle here would be. But there would be nothing wrong with adding 2 pi to it first, getting this angle, and then subtracting out pi like we were doing before. Okay, so we want to do pi 6. Pi 6 is, you also definitely want to know the conversions between radians and degrees for the special angles in the first quadrant of the unit circle. So pi 6 is a pretty small number. That's the 30 degrees. So that's this one. So I'll put that in. Sine is the numbers on bottom. So it's root 1 over 2. So that's just 1/2. And then I need to figure out my sine. So here my sine is going to be, let's see. So we're trying to think about the y values, or what if y is going to be positive or negative in this quadrant. Y should be negative in that quadrant, so we're going to put a negative 1/2. Okay, and then let's do a little bit of working backwards. Let's say that we know, secant theta is, let's say 2 over root 3. And we want to find out which thetas that's true for. So I know if secant theta is 2 over root 3, that means that cosine theta has to be equal to root 3 over 2. I know it's positive. So if it's positive and cosine is positive, then we're talking about either this quadrant or this quadrant. So I'm going to draw a line in both of them. And it doesn't have to be exact or anything. And you also don't even have to draw that line coming down. And we're trying to figure out which one it is. So we can come back to our hand trick. So we want 3 fingers on top. So it has to be 30 degrees, so pi 6. Either or would work, just depending on what you want to get the answer in. So if this is pi 6, and then, or this is pi 6. Those are our reference angles, so those usually aren't good enough. So what we would want to say is that theta is either going to be pi 6 which is fine because that's your first quadrant, so the reference angle is the same thing as a theta. Or we can go all the way around, and then this one is going to be 360 minus pi 6 will give us this distance around, because that's all we're concerned about, is just getting to the line here. So, or sorry, I said 360, but you would want to use 2 pi because we're in radians. So if you do 2 pi minus pi over 6, you're going to get 11 pi over 6. It's easier kind of to think about adding pi over 6 to 11 pi over 6 to get to 2 pi than it is to kind of subtract out, but both ways work totally fine. This is if they asked you to give you the angle between 0 and 2 pi. If they just asked for the general angles, it could be pi 6 plus n pi times k, because you can add 2 pi to it and you're going to come back to the same spot each time. For this next one, it's pi 6 or 11 pi 6, but you could also add 2 pi k to it. Sometimes if they form a right line, we'll just have one and then we'll say just add pi and it'll keep cycling around. But that's a special case. All right. The only other thing that I really kind of wanted to talk about today are the trig identities that you're going to want to know. So in pre-calculus, you cover a ton of trig identities. Only a few of them are going to be super useful when you get to calculus. The most important one is sine squared theta plus cosine squared theta equals 1. So if you know what sine theta is, you can figure out what cosine theta is very quickly. Or if you were trying to solve for something and you wanted it all in sines, you could flip it out that way. If you divided all of these by cosine squared, you would get tan squared theta plus 1 equals secant squared theta. And then if you took this first one and divided them all by sine squared, you would get 1 plus cotan squared theta equals cosecant squared theta. So these are called your Pythagorean identities. They are probably come up the most, especially these first two. And then the double angle formulas you want to know too. So sine of 2 theta is equal to 2 sine theta cosine theta. And cosine of 2 theta is either equal to cosine squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cosine squared theta minus 1. A lot of these trig identities you probably won't see till later in the year, but it's going to be super helpful to kind of keep them in mind when you come across trig functions and seeing about manipulating them. As far as angles and like which one's positive and negative, if you have sine of negative x, it's equal to negative sine x. And you can think about that as either being because it's odd, or you can think about the unit circle, because if I go up this many degrees this way versus this many degrees this way, I know sine is negative in this quadrant but positive in this quadrant. Same thing if we went all the way around to this side. If I went that way versus I went the negative way and ended up at the same angle, this one's positive, this one's negative. Cosine's the opposite, so cosine of negative x is equal to positive cosine x. And kind of the same principle for that one. If you have an angle here, that's going to give us a positive cosine, and then this angle would also give us the positive. Or say my original angle is over here. If I went back the negative way, I'd end up over here. These would both be negative in that case. But also cosine is an even function, and this is what happens with an even function. Okay, so I think we have time for a few questions. If anybody has one, feel free to send it in the chat. I'll wait around for a couple minutes until to see if we get one. Actually, while we're waiting, definitely send them, but let's work on a problem in the meantime. Let's try to do, we're going to try to find where tan of theta is equal to root 3. And let's make it negative. Okay, so the first thing we want to do is figure out which quadrants we're talking about so we can draw our line. So if tangent is negative, that either means that we're in a quadrant where sine and cosine have different signs. So let's see. They have the same sign here. They would have different signs here. So we know that's an angle. We know tangent's positive here because they are both negative, or it could be this side. And then we want to think about our fingers. So we want to think about what the reference angle would be. Let's see. So tangent is sine over cosine. So we want the number of fingers on bottom to be bigger than the number of fingers on top. So maybe this one, because if you do √3 over √1, because √3 over 2 is sine theta, and then √1 over 2 is cosine theta. That'll get us to our right tangent. So this one is 0, 30, 60, 90. No, that's not right. 0, 30, 45, 60. So we're talking about a reference angle of 60 degrees. Let's work with radians. So 60 degrees is pi thirds, and we have pi thirds here. So then you can just figure out the angle to get here. So remember, this angle is going to be 180 minus pi thirds, and you can kind of think about that as addition because this whole thing's 180, but you want to take out the pink part to just get this part alone. And then for this one, it would be 180, or sorry, actually, I did not mean to put 180 there. So that would be pi minus pi thirds. So that's just going to be 2 pi thirds. And then for this one, it would be 2 pi minus pi thirds. So then that's the same thing as 6 thirds minus 1/3. So it's just going to be 5 pi over 3. And those are our two angles. And then if we wanted more general equations, we could say plus 2 pi k and then plus 2 pi k here. All right. Well, we didn't get any questions, so we'll end here, but definitely practice the unit circle. And thanks for joining us.